and VLSI. So there are at least 10 patents in which his
Attendance are
name
left
has
in
been credited
halfway.
to him. Thank you, sir, for
Sessions
accepting
are
our
there
request.
till
Now
ending,
the session
and
is handed
the
over to
second
you,
session
sir.
is going to happen next month. Maybe, sir. Okay.
Sir,
Yes, sir.
am I audible?
Yes, sir. Even I was there at that time. Okay. Yes, sir. I was there. Uh, Sir, I'll get back you after sometimes. I'm in a session actually. Once I complete it, I'll get back to you. I'm in a session actually. I'm giving one session for some other class. I'll get back. Yeah. Okay. Hello. Hello. Is my
Sir,
voice audible, ma'am?
sir. Yes, sir, yes.
Yes. Yes. Yeah. Yeah. There was some small technical glitch actually. Can you just confirm me whether
Okay.
my PPT is visible or not?
Yes, yes, it is visible.
Okay.
It is visible, sir.
Yeah. Now it is visible, ma'am.
Yes, sir.
Okay. Okay. So yeah. Just 1 minute. I'm just yeah. Yeah. So very good afternoon to everyone. So first of all, I would like to thank Dr. Saroja, the HOD of ECE, Siddharth Institute of Science and Technology, and Mr. Ruben, the faculty of ECE, Siddhartha Institute of Technology, and again, but last but not the least, Miss Madhavi for giving a great introduction for me. So now here we go. So as given as an introduction, as ma'am has given to all of you, so I'm going to take a session on digital image processing actually. So it is more or less a hands-on session what I have planned it. But so due to the lack of time, what I did is whatever the hands-on session what I made it, I'm converted that into a practical insight. Okay, so in MATLAB with using the MATLAB. Okay, so here we are going to study what is digital image processing, what are the various steps involved in the digital image processing, and when we apply these image processing concepts in using MATLAB, what are the outcomes we are going to get? And that is what we are going to see. Okay, so now let us, without wasting the time, let us start the things. Okay, and whatever the material and whatever the images I'm going used for my PPT, it has all been taken from digital image processing course uh, by Brian Mack, who is working in Dublin Institute of Technology, and the reference resource is digital image processing by Gonzalez. Right. So always whenever I give a session on digital image processing, I'll always start with this sentence known as one picture is more worth than 10,000 words, and it is true. So all the all the views, whatever we want to express in terms of sentences, everything can be expressed in a simple circuit or a simple picture, right? So yeah. So now what we need to have in order to have a full knowledge on this digital image processing, okay, we should have some prerequisites like we should have some knowledge about what is a signal and what makes the signal to modify. Okay, so that is what we call as a system. A system is the one which operates on the signal so such that the signal can be modified or manipulated for the effective usage. Okay, so this basic knowledge we require, and since we have to do some practical things on it, we require some few knowledge about MATLAB. MATLAB is a matrix laboratory. Okay, it's a tool where the processing of all the data will be done in terms of matrices only. Okay, now these are the bibliographies. Maybe some will be in Japanese also, but all the books are same. So Gonzalez books are there, who has edited more than 5 to 6 editions, out of which two are more dedicated uh, for practical approach only. And apart from that, there is one beautiful book, The Fundamentals of Digital Image Processing by A.K. Jain, and Two-Dimensional Signal and Image Processing by J. Lin. So these are the bibliography. These are the some well crafted books for image processing. These are the books. So you can see the 3 editions of the books of digital image processing. Okay, the black pad, what we call it as a second edition, is more or less theoretical, and the third edition is the one which has some MATLAB programs also for you to practice. Now, as said, this lecture is going to cover digital image processing history, the art of examples, and the key stages. Now, so you might have studied this, okay, but anyhow, just brushing it up, okay. So, what is a digital image process? What is a digital image? An image is image which is representation of a two-dimensional information as a finite set of digital values. Okay, so that digital values we call them as a pixels. Okay, so now if you see here, uh, we have a simple image which is an image version of an illumination source. Okay, so when it is passed through an imaging system, the representation will be a digital image. Now the one which is in vertical in x-axis and y-axis, you can see it is not a perfect shape. Okay, so all the pixels are just like a squares. Whereas the same projection, if you see in the image plane, it will have a perfect plane or a perfect shape. Okay, so this digital image, each and every each and every pixel will have its own value. Okay, then so this is about a theoretical base. Now, if you see the image of a ear of a deer, okay, now when it is zoomed, you can see that one pixel value is this much, and when we zoom it, it is not a perfect curve. Okay, so the edges are represented in terms of different squares, and each and every square is not having a common color. If you say so, somewhere here, if you see, it is black. Somewhere you see here, it is somewhat gray, and here it is somewhat white, and here it is pure white. So this is known to be the content of that square, what we call it as intensity value. Pixel value we call it as, it is known as the intensity. Okay, now here are the other examples how we can do. So now if you see here, one pixel is represented in one box. Okay, so the inside information is fine, but the border information is not so smooth. This is because we have used one sample per one point. Okay, what if we are using three samples per a single point? Then it is called as this representation is called as red, green, blue. In the previous case, each and every box or each and every square is represented with a single value. Okay, or we call it as a single sample, right? Then that representation or that value we call it as an grayscale value. Okay, and that is obtained from black and white images or grayscale images. If if the same point is represented with the help of three samples, okay, so let the three samples be red, green, and blue. Then that image is considered to be a color image. Okay, so for suppose if we have four samples, okay, then it is known as a, what we call it as an hue image. Okay, so it contains three intensity levels. So one is red, blue, green, as well as an alpha, which is known to be the angle at which the value is being changed. Okay, we call it as phase in general terms. Okay, whereas in image processing terms, it is known as an alpha. Okay, so but this course, whatever we are discussing as of now, it completely covers on grayscale imaging only. So not about the color images, not about the hue images. Now these are the three differences what we have. The first one represents where each and every single value is represented with a single sample, and in the second image, single sample has been represented with three values, and in the fourth one, it is represented, and the third one, it is represented with four values. Okay, then what is the purpose of image processing? Very first question we will get it. The main purpose is to improve the pictorial information or visual interpretation, what we call it as. And the second one is processing of the image for data storage. Now everything is digital. Okay. So when everything is digital, we need to have that information to be stored somewhere. Okay. So once what is the use of storage is you can use for future purpose or you can transfer that information from one point to other point, remote location for some processing purpose. And if we have that information, we can represent that image for the future for some other projects or something like that. Suppose say there is an image which is having 256 pixels. Okay, so just the 256 pixels information will be stored in somewhere. Okay, and this storage data when it is transformed from say some Bangalore to Delhi, right? In the Delhi, they should be able to get the 256 pixels information, and they should see what is that representation also. Okay, so that is that is the second purpose of image processing. So mostly this interpretation is done by a machine, not by a human. If it is a human, we will train. Our brain is trained for that. But for machine, it is not so. So we will be training with this 256 pixels information. Okay, but however, there is a paradox here. So there is an argument about where image processing ends and fields such as image analysis, computer vision starts. But overall, if you see, image processing is a basic for anything. Okay, whether it is an image analysis or a computer vision, whatever it is. Okay, but there is a paradox, so that we can't avoid. Now, in how many stages this digital image processing is um, classified? This digital image processing is classified into three levels. One is called as a low level processing, then called the mid level processing. At last, we have the high level processing. Okay, so if you see in a glimpse, the low level processing where your input will be image, your output will is also image. Okay, then what we are doing? So we can do noise removal, we can improve the image sharpness, all these things. Now coming to the mid-level processing, your input is an image, whereas your output will be an attribute. Attribute means its physical characteristics. If you take an image, what is the height of the image? Okay, let us say the height of the image is 10 centimeters, you are saying. Okay, so that 10 centimeters is known to be an attribute. Okay, so that is what we call it as object recognition and segmentation. Okay, so these attributes we can get through object recognition and segmentation. Next, high level processing, the input itself is the attributes of the image, and the output will be how good you are going to understand it. So usually this will be done in a machine. So this is where the computer vision will come into picture, or the robotic visions we call it as nowadays. Okay, so this robotic visions, everything will come in the high level processing. Okay, so altogether this low level process, mid level process, and high level process constitute completely digital image processing. Some will argue that it is image analysis, some will argue it as a computer vision, but that is not our point of interest. Our point of interest will stop at mid-level processing. Okay, that is where our input is an image, output is image. At the same time, our input is an image and output is a attribute. Now coming to the history of digital image processing, so image digital image processing was way back from ancient times, but authenticatedly in 1920s is the first one of the first applications of digital image processing was in paper industry. Okay, so when that invent paper has invented and it has got circulated. Okay, so when they try to transfer the information through papers, they required some clear pictures. Okay, so with the photography itself, it came into picture, right? So this was the first image. Okay, what this was a first image, what I can say as a processed image using digital image processing technique. Okay, so in and it has progressed from 1920s onwards. So we are not interested in it. And the more important, the more applications of digital image processing as found with the development of space technology. Okay, and when we try to collect the images from the space. Okay, so that is what this a picture of moon taken by Ranger 7 probe minutes before landing. Okay, then so then they try to study about the human vision, actually how the vision works, and based on that human vision mission system, they try to develop the missions which will match the human vision. Okay, so actually the best image processing system what is present in the complete world is our human eye. Okay, so now with the invent of that, we this image processing has found its root from its roots. It got some branches like image enhancement, restoring artistic effects, medical visualization, medical images, industrial inspection, then law of enforcements, human computer interfaces, like this. Now, if you see the visible spectrum, okay, so we have the visible spectrum very, 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 very small. If you see this graph, actually there is an electromagnetic spectrum arranged according to the electrons per photon, where visible spectrum is very less when compared to gamma rays, X-rays, ultraviolet, infrared, microwave, radio waves. Means the meaning is we see a very few information only, but there are lot of information which is not visible to our naked eye. Now, for that, so with that visual system, if we want to process that information, invisible information to the human eye, okay, so that we need to check that is where your image processing will come into picture. Okay, so now if you see here, so here, so three types of images are being given. One is a medical image that is known to be an X-ray, and the other is an image which is taken from an airspace. Okay, and one more image is of a PCB. Okay, so now uh, we can apply our DIP. So if you see the first image of X-ray, it is not so clear. So it is the content of only black and gray content. When it has been enhanced, you can see the clear picture of some bones, okay, some tissues are there, right? So this is where in medical field that's digital image processing will find. Now coming to here, the airspace image, the image that is taken at the initials using a cam, okay, it consists of a lot of noises because of the fog, because of the clouds, we can say. Now once it is enhanced, we got a clear picture. Now, in the similar fashion, a PCB is there. Okay, so a PCB is induced with some noise, and after enhancing it, we got a clear picture. And here we can see how the connections are there. Okay, even if the connection is being broken, that also can be visualized. Okay, so this is how this image processing will be utilized for all of us, right? And now this is that Hubble telescope image. Okay, where the image has been taken from an Hubble telescope, which can be converted, which can be enhanced, and it can be clearly visualized, which is known to be the galaxy. Next, nowadays, we can't imagine any entertainment media without the VFX works, visual effects. Okay, so this is majorly done with two mats actually, known as a blue mat and green mat. Nowadays, we focus more on green mats, but early 2000, they used to work with only blue mats. Okay, so green mats are more, what you say, more realistic in nature, whereas blue mats are not that much realistic. Okay, so these are some applications. So X-ray missions, then gamma ray missions, then magnetoresonance. These are the medical images what I'm showing you. This is an ultrasonic images of a fetus which is developed. Okay, and these are the 3D tomographs. Okay, so if anyone who has been diagnosed went for an hospital by any chance, they would have experienced this CT scan. Okay, and the image, the first line, this first line, it shows the 2D tomographic image, whereas the second line shows the 3D tomographic images. Okay, right. Now, this is a 3D this is an image which is developed by a 3D tomograph where the internal structure or the 3D view of a human skull is being represented. Okay. Now these are the other images which have been taken from 3D tomograph, human brain cancer cell. So you can see the cancer scale, how beautiful it is for looking, but actually it is very hazardous to the body. Then there is an ice block, okay, of a human brain. Okay, means what we can say, the corpus brain, means the dead body's brain, we can say. Then this is one of the example of an MRI scan of a heart of a dog. Okay, so if you want to see the exact structure, we are using a method called as edge detection method, so that we can get the exact structure. Then these are the images of geo information systems. Then applications, industrial inspections, the bottle filling system. This is a bottle filling system. So using image processing, we can check whether the bottle has been filled completely or not. And this is in pharmaceutical field. This is in our PCB design, and this is in our nanotechnology field. Okay, so what not? Everywhere this image processing is there. Okay, so and this is PCB inspection tool where this will see for each and every connection whether the each and every connection has been done properly or not in a PCB. Okay, next law enforcement. So this is for our so the one who crosses the signals. Okay, so there they will be using this image processing to capture the number plate. By that they will enforce some laws and give some challans. And these are for our biometrics. Okay, so for authenticating your systems, your presence. Then this is human computer interface. So this is the one which is we called as AV metaverse. Okay, so artificial augmented reality and uh, visual information. Okay, so now all these applications are based on certain stages. Okay, now if you see, maybe in your curriculum you might have studied about these key stages of digital image processing. Okay, so where it starts from image acquisition, image enhancement, digital image restoration, some morphological processing, segmentation, object recognition, representation, description. So these are the what we can say 7 stages. Okay, but there are two different some two stages which are hidden. So which are mentioned as color image processing and image compression. So which can be used at any stage of this complete cycle. So now let us see one by one. Now this is what the image acquisition is. With the help of a camera, we are going to capture the image, and that is represented in terms of digital pixels, that information. And then we are using some enhancement techniques so that the visibility of the image will be more clear for us. Okay, so now here you can see the example of an barley seeds. Okay, so when it was taken and after an enhancement, how it is looking. Okay, so there is a clear visual clarity when compared to the first image. Now, the next one is image restoration. So, image restoration is the one With the help of the neighboring information, we are going to restore the actual image. Actually, we won't get any we won't have any proper picture, but with the information of the same picture, we will be restoring the other parts. This is just like if you have a old photograph in your home, your maybe your grandparents or something, and if you go to a studio and ask them to clean it, what they will do is they will use the same information that is present in the photograph, and they will try to reconstruct it, restore that missing part. Okay, so that is what is called as a image restoration. Okay, and this is a satellite picture which is taken on a moon. Okay, and once it came to the earth, so the image is in this fashion, and after processing image restoration process, they got the image, a clear image, which shows some rock is present on the moon. Then is the morphological operations. Okay, morphological processing means addition or deletion of the information from the image. Now, if you see, just for example, there are two pixel images of an fingerprint. Okay, and both are getting fused, and that is getting processed. I can tell a best example. Whenever you buy a new mobile, and if you want to authenticate your using your fingerprint, you have to give the fingerprint for more than 8 times, so that it will take the information from all the angles. Right. So that is where when once you give the authentication, and later in the later stages, if you want to operate at with any angle, if you press or if you give your fingerprint, it will take it. Okay. So that is what a best example of a morphological operation. So it is not addition or not, it is not an subtraction actually. It is we can call it as union, means combining, intersection, removing. Okay, so combining. So it is it's more or less deals with the set theory of mathematics, union, intersection, all these things. Okay, then comes the segmentation. So segmentation is a major application of image processing, right? So nowadays we are doing this morphing, right? Deep fake AI, we got it. Everything is based on this segmentation process. So remove the unwanted part. Okay, and if you want to add any required part, you can place them properly and you can do so. Then comes the object recognition. This is the most typical part of image processing. So from your segmentation, you will get some information, okay, of the image in terms of values, some quantities. Okay. Then with the help of the quantity, the machine has to recognize that object. Suppose say if I tell all apples are in red color, then the machine should give an answer that whenever it finds a red color, it should give the answer as apple. But all red colors are not apples, right? So this is where the contradiction starts. Okay, so if you give this information, all the red color to the machine, and if you say that any red color that is identified as apple, then your complete assessment or your complete process is wrong. So what we have to tell the machine is all the red colors, all red colors are not apples, but some part of the apples can be red colors, because nowadays we have the apples which are coming with green colors also. So that is where we have to define the attributes of the object. So apple means there will be a definite shape. It will be in a round shape. It will be having a cylindrical shape. On the top, it will be having a stem. Okay. On the bottom, it will be having some small brown color pieces. Okay. So these shapes we have to define. What will be the angle? All these things. If you sell, then the machine will tell that any object which is recognized as red color, then it will look for apple features. If it is matching, then it will give the answer as apple. Okay, so all these things is known as the information that is collected. That's information primarily we will get from segmentation, and in object recognition stage we will identify them. Then once you identify, we need to represent them. Okay, we need to reconstruct them. So this is just like taking the picture and taking the picture of an apple and converting that into a photograph. Okay, so once it understands the Apple features, it has to represent it. Okay, so that representation and description from the features, from the information that is our that the machine has got from segmentation and object recognition will helpful in representation and description. Okay, so this is a best example. This is a image, okay, which has been we have taken at the starting. Okay, a conical image. This is the image what we have taken. By the time it comes to representation, see we have different representations. So if you see the first representation, graph representation, it is not exactly the same representation. We keep on joining this. I'll be using this pen. Okay, so if we keep on joining this, so it will not get the shape of the image what we require. Okay, so this is not resembling it. So then what we can do, we can use the number of points between these points and we can avail that state. So description is more or less applying some mathematical tools on that information so that the shape can be restored. Next is image compression. So what we are doing all these things, we collect more information, we will store somewhere, okay, and it has to be transferred from one point to other point. Suppose say the size of the picture that is taken is 1 GB. Okay, now this 1 GB cannot be transferred to the remote place as such. So it takes more bandwidth, it takes more time. Okay, so it takes less, the image will be transferred at a less time. So what we need to do is we need to compress that image, that information in such a way that when it is restored, okay, when it is decompressed at the sorry, it has to it we have to compress that image such that it will be transferred very fastly. At the same time, once it is received, it has to be the same image has to be restored properly. I can quote a best example here. So when you take a picture from your mobile and if you send that picture in WhatsApp, the image quality will be reduced. If you take an image of say some 10 MB, the size is, and when you transfer the 10 MB of image through WhatsApp, it will be compressed to say some 1 MB and it get transferred. Okay, so the image that is received at the receiver's end will not be of the same quality which is taken from the original phone. So what we need to do is, if you don't want that image quality should be reduced, then we have to send this image in terms of a document. If you send that in terms of a document, that whole 10 MB will be transferred and image quality will not be compromised. Okay, so that is the reason why we require compression techniques. So we should go for a compression technique such a way that the image information should be compressed, but it should not be compromised. Compromised in the sense that complete information should be restored at the end. Now, nowadays everything is in color. Actually, our world is full of colors. So we require color image processing only. But whatever the image processing we have studied till now is just an grayscale image processing. Okay, but grayscale image, what's the difference between grayscale and the colored images? Grayscale has only one intensity level for per pixel, whereas color image has three intensity levels per a picture. So that is red intensity, green intensity, and blue intensity. Okay, so this is the best example of an color image. This is known as a thermal image of a human brain. Okay, so the first image is taken, and after color image processing, we got this. No doubt, the color image processing also will have the same stages, but what we do is we will be doing three times. Means for red pixel, we are going to follow this steps. For green color also we'll follow the same steps. Okay, for blue color also we follow the same steps. Okay, so totally we are going to have three steps for a single processing for a color image. Okay, now what we have looked is what is a digital image, what is digital image processing. We have seen some history and examples of digital image processing and key stages. Okay, Now, what is important is we have to process that image using the MATLAB, right? So that is our image processing using MATLAB. Okay, so as given introduction, MATLAB is said to be a matrix laboratory. Okay, so it is the only authenticated tool for image processing. There are many other tools. If you use Python also, you can use it. But this is highly validated tool for image processing. Okay, means what are the results we are getting in this MATLAB are more accurate than when compared to the other. Okay, authenticated I'm saying means licensed one. So that's why most of the research articles will have this information only. Now, this MATLAB is having different toolboxes. Okay, so we have a signal processing toolbox, we have control processing toolbox, we have communication toolbox, we have control system, we have instrumentation toolbox. Okay, we have neural network toolbox. Nowadays, the MATLAB is associated with AI also. Okay, so the latest version that is MATLAB 2024 B. Okay, is available with AI version. Okay, so it supports the AI artificial intelligence also. Okay. So the toolbox, what we have to have for doing this image processing is image processing toolbox. Okay, so this you can find while you are installing the MATLAB. Okay, on your systems, it will ask for what are the toolboxes by default it has to add. Okay, there will be a checkbox for all the toolboxes. Whichever you want, you can install it. Whichever you don't want, you can just uncheck it. Then, so as usual, the toolbox will have, we can write our own code. Okay, so in terms of MFIs, at the same time, there are definite functions which are defined in toolbox for accessing for doing the process. Okay, now let us say color corrections. So we have color corrections operations like improving the brightness, contrast adjustments, quantization, then color translation to other colors, one from one color to other color. Okay, so that can be done. Then image registration can be done. Alignment of two or more images means fusing of two or more images can be done. We can do, of course, we can do the segmentation also. So a lot more we can do it, but I have listed some basic things here. Right. So what are the operations we can do? So the coming to the operations, we can do the neighborhood operations and block operations. Can anyone tell me what is meant by a neighborhood operation is? Let's have some small interaction. Yeah, any student can just tell me what is meant by this neighborhood operation. You can answer in your chat box. Okay, fine. Then, yeah. So neighborhood operation, block operations is nothing but your filtering process. Okay. So taking the information from the next pixel, very next pixel, and just doing some operation. So next comes filtering, linear filtering and filter design. Then comes the transformations. Then high dynamic imaging by combining the multiple images. So yeah. Okay, and de-blurring the images. So these are some operations what we can do now. So we should, whenever we are working with MATLAB, so we should ensure that what image formats we have. Okay, so the image formats that is supported by MATLAB are BMP format, HDF format, JPEG, PCX format, TIFF format, and XWB format. So PNG format is not supported. Okay, even though if you give the PNG image to MATLAB, it will convert that into a JPEG image or a BMP image, bitmap image. Okay, so like this it will convert. Then TIFF image is an image that is collected from your web directly. Okay, it is a graphical image. Okay, so these are the image formats what supported by MATLAB. Okay. Next, so the type of images we are just having. So MATLAB will process mostly on intensity images and binary images. So intensity images, otherwise known as a grayscale image, what we call with the different grayscale levels, and binary image is known to be black and white image. Okay, so these are the two image formats what MATLAB supports. It doesn't mean that it won't support the color image processing. Of course, it will support, but we need to have one more toolbox called as color image processing. Then we have an indexed images. Okay, so this is a practical way of representing a color image. Okay, so where the image will be transformed into three matrices, where the first matrix will consist of the red color intensities. Then the second matrix will have the green color intensities. Third matrix will have the blue color intensities. Okay, all the three matrices will be of same size. So that is what RBG images we have. Then yeah, so these are certain commands what we use for the color enhancement or enhancement of the image. Now I hope you know what is meant by histogram. Okay, so histogram is the distribution of the intensity levels that are present in the image. Okay, so now if you take a grayscale image, it will have different intensity levels at different points. Suppose say for an image, so usually grayscale image will have 0 to 255 to 255 pixel values. Now, how this 0 to 255 intensity levels are distributed over that complete image is represented in a graphical way. That is what is called we call it as a histogram. Now, there will in the image there will be certain parts where the intensity levels are low, where the intensity levels are high. Okay, now you want to equalize them. Equalize them means we have to normalize them. Okay, at the same time the image should be restored. Then that process we call it as histogram equalization. Okay, so for that the command what we can use is histeq square brackets. Okay, now what we have to do if we want to do the histogram equalization for an image as which is in JPEG format, we can give it as histeq. Okay, image name. Okay, let us say image name is image dot jpeg. If you give that format, now you can see the equalized histogram. So an example, a collection of coins, a photograph of a collection of coins has been taken. This is before the equalization and this is after the equalization. So here you can see we have improvised the intensity levels to higher part. Okay, so the low intensity levels that are present here are converted to high intensity levels. So always remember low intensity means black, high intensity means white. Okay. So this is one function what you can use for your histogram equalization. Otherwise, you need to write the process. So there is a definite process how to find out how many times a pixel value has been appeared. Then you're going to normalize that. Then all the pixel values will be replaced with that normalized values. So you might have done some working on it also. So everything can be done with the help of a single function. Next is image adjust is one more command which is used in your MATLAB for adjusting the contrast of the image. Okay, so whenever you use this command, the contrast of the image is going to be improvised by 1%. Okay, and 1% means both the low intensities as well as the high intensities will be improvised. Okay, so you can use the same syntax, that is IMA image adjust. So IM is known to be image adjust image format dot format. Okay, so image format image name dot JPEG you can make it. So this is how you can see the image adjustment. Okay, so now you can see here, this is an biometric image of a thumb, what we have taken, and we have adjusted it. See here, you can see in the MATLAB, the first image or second image, I'll say. Okay, or image 4 is represented here. Image 4 is the intensity levels are improvised by 3%. So if you give I, okay, if you give I, okay, so now what happened? The I is your image information, which is known as fp2.bmp. Okay, so it has been collected to a variable called I. I have improvised by one time. Okay, next the same I2 has been improvised for second time, and the same that improvised second time improvised image has been adjusted for the third time. So three times. So for one time 1%. So three times I have adjusted. So totally 3% the total image has been enhanced. Okay. Now this is adaptive histogram equalization. Okay. So histogram equalization we have seen, that is a normal general process what we have. Okay. And then is an histogram adaptive histogram equalization where the uh, adaptiveness is, means say some high intensity levels has to be improvised to high levels, and low intensity levels has to be normalized to lower intensity levels. Okay, this is what is known as adaptive, right? So depending upon the high intensity values, that will be equalized. So for this, usually we perform a Cauchy equalization algorithm that is called as contrast limited adaptive histogram equalization. Okay, so it is an alternative function for histoequalization. Okay, works on the entire image. Okay, and if you want only certain portion of the image to be equalized, that also can be done. Okay, so here adaptive equalization is followed for the coins actually, not for your background. You can see that how clarity it is when compared to the first image. Okay, next actually this should be the first command which has to be shown, but I have started with the equalization. But anyway, no problem. So im read, okay, im read, image read is a function that will read the image, okay, and it will convert that image into a two-dimensional image. Okay, usually it will return a value of 3 by 3. Okay, 3 by 3 matrix only it will convert usually. Okay, unless the image is very large, it will convert that into a 3 by 3 array only. Okay, now image view is one more hmm, command which is used to visualize the image, whatever the image we have processed. If you want to view it, you can use im image. These two you can see here. So in this part, okay, I'll just highlight this. So see here, this is your image read function, and this is your image view. So whenever you use image view, okay, it will throw a graphical representation in terms of an image. Separate picture it will show. Right, right. So this is one more example: image read and image view. Okay, and then image write. So this is somewhat important command what we use in MATLAB, which is used to convert the file format of the image. If your image is in JPEG and if you want to convert that into PNG, okay, so you need to represent that, right? Now see here, this is the command used to change the format of the red file. By using this command, we can change the formats from one form to other form. Now here, uh, this is your original image format. Okay, if my image is in JPEG format, I have to give it as image.jpg, and this is the format too, is a format to which you require it. Suppose if I want to get it into PNG, then you have to make it as imwrite image.png comma image.jpg. So now the JPEG image will be converted to your PNG image. Okay, next there is one more command known as image info. Okay, so which will give the information about the image which you intend to process. Okay, so it gives the information such as whenever you use this command for an image, it gives the information of the size of the image, what is the position of the pixels, how many rows are there, how many columns are there, okay, what are the different intensity levels, all these things will be given there. To obtain this, we can use this in IMF info. Next, image subtract. Okay, so now, so if you want to remove the background of the image, suppose you have gone for a passport for a photo studio, and if you want to remove the background image, okay, immediately you can use a command known as image subtract. Okay, so what it will do? So it will remove the background from the front ground. Means the lower intensity levels will be removed from the separated from the higher intensity levels. Now here there will be a question, sir. What if it removes the information of the photo of our actual information itself? Then you can define the percentage how much it has to subtract. Okay, so now you can see here there is a simple command which has been I have used, that is background equal to im open the image format strle. Okay, so strle disk comma 15. So whenever you give, this will give the background information of the image, and it will be assigned to a variable called background. Now what you can see, if you want to just view the background, im view background, if you type, you will get the background information, only the background information. If you are satisfied with that, then you can subtract the information by using image subtract image dot format comma background. This is the background what you have got from this command, background equal to image. Okay, so now if you are not satisfied, then you can increase this value from 15 to 20 or 15 to 30 like this, and then it can be the background can be removed as per that. Okay, so now here you can see the best example of using the commands. Okay, so I am reach. So first one is the image. Okay, so then we have viewed it. With 15%, I have removed the background. So that background is this much what we have, and now that background I have subtracted from the original image. Now you can see here how the images are, how the image is looking like. There is the information once I remove the background. So this information I have removed, this white color information. Okay. Now, image resize. Now, my image is not compatible for my processing. At that level, you can resize the image. Okay, so the resizing can be done with the help of im resize command. And again, the value should be a real value, which is between 0 and 1. Okay, it means it can be 0 0.1, 0 0.2, 0 0.3, like this you can make it. Okay. Okay, so if it is from 0 to 1, you can reduce the size. If it is greater than 1, you can improvise the size. But all the time, the value should not be a negative value. Next is the image rotation. Image rotation means you will be rotating 90 degrees, 180 degrees, 120 degrees, right? So for that, you can use the image function as image rotation and angle in degree. Okay, so now see here. So here I have taken an image. Okay, I have rotated with 35 degrees centigrade. Okay, and I gave a bilinear rotation. So this is a simple operation what we are using, bilinear operation, then linear operation. Okay, so Gaussian operations, many operations are there in rotation also. So what it will do, it has been, this image I has been rotated to 35 degrees centigrade bilinearly, means in an x-axis. Okay, so axial rotation, bilinear rotation, cylindrical rotation, many rotations we have. Okay, so this is one of the rotation of it. So if you just type 35, it will throw an error. So you have to mention the uh, type of rotation also. Okay. Next is image cropping. Okay, so this is one of the command which is used to crop the image. If you want to remove some unwanted part, or if you want to crop the image, you can use this command, and this function will crop in a rectangular fashion. not in square or not in cylindrical. Okay, so it crops in rectangle fashion. Now see, this is a simple syntax, and this is an example. So only this information, the information that is present in your red color. Okay, so if you want to crop it, and these are the unwanted things. Okay, you can crop it. Okay, so you can give rectangle. Right, by basically it is a rectangle cropping only, but if you want to be more specific for different cropping methods, you can go with. If you want a circular, you can put is CIR here. So if you put CIR in this here, okay, you will get a circular cropping. But by default, it is a rectangle, even if you are specifying or not specifying it. Then I am erode. Okay, so this is known as mm, an erosion operation. Okay, so where uh, more black content will be given on the for the image, not the white content. Okay, so we can call this as an erosion process. Then IM to BW means grayscale image can be converted to a black and white image with the help of a command called IM to BW, right? And you can define the levels also, the binary levels also you can define here. Okay, so there is an alternate means IM to BM means convert grayscale image to binary, black and white image. If you want black and white image to binary, you can have BW to IM. Okay, and if you want to know what is the levels, grayscale levels, then you can use a command called as gray the rash. Okay, gray the rash means it will give the how many intensity levels are present in that image. Okay, next is a dollar command. Okay, I think this is very new to you. Okay, so a dollar command is used to fade the image. Okay, fade in, fade out, you might have heard about it. So in order to fade the image, you have a dollar. Okay, so this zero point 0.5 is a constant. Okay, that can be defined from by the programmer. It can be from 0 to 1. Okay, so amount of fading you have to do. Directly you can make it as dollar equal to zero point 0.5 into image dot your format. It can be JPEG or whatever it might be. Okay, then if you want to combine two images, fusing we call it as. Okay, so simply write combine image 1 plus image 2 with the format again. Okay, next image conversions. This is gray to indexed coloring. Okay, you can see here this is a grayscale image where we have different grayscale levels, whereas if you see the indexed level, you have only three levels: one pure black, a little bit lesser black, and elephant black. Okay, now index to gray, ind to gray command, you can use it. Then rbg to gray image, you have a command called rbg to gray with whatever the image in the brackets you have to mention here. Then RGB to indexed IND, right? So these are the basic image enhancement commands what are available in the image processing toolbox. Now comes image analysis. Okay, so this image analysis is more about your detection of the edge detection, more that is segmentation we call it as. This segmentation are come divided into three parts. One is edge detection, boundary tracing, and quadri decomposition. Okay, but anyhow, quadri decomposition is a new for you, but edge detection and boundary tracing are already there in your curriculum. Okay, so now without wasting much time, I'll just show you what is meant by this edge detection. Edge detection, which detect the edges, okay, of the image. Mostly it is useful for your biometric applications. And here a canny edge detection method is applied. Okay, so it will have different threshold values. Okay, to detect low level boundaries and high level boundaries. We call it as strong edges, weak edges. Now see here, if you see edge image format dot canny, whenever you put that canny, okay, so the edges will be represented in this fashion. Okay, whereas the original image is just a lines, whereas this is across the lines, the borders will be drawn and it will be showing the information. Next is the toolbox which has this boundary tracing. Okay, black and white trace boundaries and black and white boundaries. Okay, so let us first see black and white trace boundaries. Okay, so BW trace boundaries, image format, rows, columns, and n. And black and white boundaries simply images. Now see here, both we have used here. Now if you see this tab properly, so first we have taken an image, we have converted that into a black and white image. Okay, then uh, this is your first image and this is your black and white image. Okay, from black and white image I have dimmed it. Okay, means I have resized it, then rows and columns, some operation. Now see here, boundary, black and white trace boundary, image show I. So this is your black and white tracing, and this is a particular figure which show which I am very much specific about it. Okay, so which row, which column we have to see, that we can see the third image or fourth image. That is how we can see here. Now this is a quarter decomposition where the information will be converted into its threshold levels at different uh, rows and columns. You can see the white dots here. Okay, so these are the threshold levels for this image at different positions. Okay, and next, as usual, the noise removal. This noise removal will have different types of filtering: linear filtering, adaptive filtering, median filtering. Okay, so this is a histogram as is, we have seen. Okay, so when you apply the histogram, okay, so this is the graph what you are going to get. Distribution of all the pixel levels of this image in a graphical representation. Okay, so I think in this, yeah, I hope I have explained in this smaller time what is image processing, what are the commands which are used for you in the image processing toolbox. So if you have any further questions, you can just contact me, okay, through your coordinator. And if any student is interested in doing the projects, okay, they can readily approach me at any time. Okay, so I can mentor you to complete your final year projects also in image processing. Okay, it doesn't mean that I'm going to do it. Okay, so just going to mentor you for completing the project. Yes, thank you. And if you have any questions, you can post in the chat box or you can just raise now. The media is open for you. Madhavi ma'am, are you there?
Yes, sir.
Yes, yes, ma'am. So I think,
Students don't.
yeah, I took 1 hour, 10 minutes, more than that. Is it sufficient
Yes,
or still
yes.
if you want to continue, I can continue, not an issue.
Yes, it's your wish, sir. If you want to continue, you can. And otherwise,
Yeah.
we'll end the.
Yeah. So let us see the response from the students. Later we can decide. If anyone is
Yes, sir.
interested, we can just go ahead.
Student, though, if you have any questions, you can ask, sir. Sir, okay, sir. So no one
Okay.
is responding, no?
Yeah,
Yes,
yes, ma'am.
sir. Thank you, Rajesh Garu, for your valuable time, and it's a wonderful session.
Yeah, thank you,
Yes,
ma'am.
yes, sir. With this, we can end the session, sir. Thank
Okay.
you.
Okay, ma'am. Thank you. Yes, thank you, students. And if you want to any query about this, you can just contact me through your coordinator. Okay, so I'll be happy to help you. Yeah, thank you. And thank you for this opportunity, man.